Hi ladies, this is Mrs. Blaufuss with lesson 3.2. It's about constructing perpendicular bisectors. So in the last lesson we constructed duplicate segments and we constructed duplicate angles. But in this lesson we're going to go a little bit further and actually construct specific measured angles, which is perpendicular, which means 90 degrees, and specific distance segments, which are bisectors. So we have a couple definitions to start out with, and you see this on your guided note sheets, but it says lines L, M, and N bisect AB. So line L line L, line M, and line N all bisect AB. So what does it mean to bisect something? Well, any line that bisects a segment, the line goes through the segment. So that's all a bisector is a line goes through the segment at the midpoint, and therefore cuts the segment into two equal pieces. Or two congruent pieces. In this case, O is the midpoint. So right here, O is our midpoint. O separates AB so that AO is congruent to OB. All right, our next term is perpendicular. So in this next diagram, you can see that J, L, K are all perpendicular to AB. So perpendicular means that the lines intersect with the segment at a specific angle, and that specific angle is 90 degrees. So the line intersects the segment at a 90-degree angle. That looks a little weird, but it's because of the font. Okay, so then the last term, if we put the first two together, it says L is the perpendicular bisector of AB. Well, we know what it means to be perpendicular, and we know what it means to be the bisector. So a perpendicular bisector is the combination of those two definitions. So the line intersects the segment at a 90-degree angle and passes through the midpoint. So in this lesson, now that we know what a perpendicular bisector is, we're going to actually construct a perpendicular bisector. Okay, so some of these definitions we already have, but a segment bisector is a line that passes through the segment's midpoint. Perpendicular bisector is a line that passes through the segment's midpoint at a right angle. And then this next term, equidistant. Equidistant simply means equal distance from. So a point could be equidistant from another point, or sorry, 2 points could be equidistant from one other point. So when we say equidistant, we just mean the same distance. Okay, so this perpendicular bisector conjecture, this conjecture says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So we're going to use this conjecture to actually construct a perpendicular bisector. So the first step is to use our compass to draw an arc from point A and use the same setting to draw an arc from point B. So first we need to actually label a point A and a point B. And it doesn't matter where on your segment you do that, but somewhere you need to label A and B. And usually we use capital letters. So I'll do that. Okay, so now we're going to use our compass. And with our compass, we're going to measure the distance between A and B. And we're going to use this setting to make an arc. Now we're going to do the same thing over here. And your setting shouldn't change. The distance from AB is the same distance as it is from BA. So you want the point where there's two arcs intersect. Now your next step, you have a couple options. You can either change the setting of your compass, or you can make the same markings below. So if I chose to keep my compass setting the same, I just need 2 points to form a line. So I can either do this below, because my perpendicular bisector conjecture says if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So this is the same distance between both endpoints. Or the second option is, like your instructions say, is to change your compass setting to make it smaller or larger, it doesn't matter. But I'll make mine smaller, and now I'm still saying that any point on this arc is the same distance from A as it is from B. So any point on this arc is that same distance from B. So now I have 2 points, and 2 points form a line. So if I connect these 2 points, then I get a perpendicular bisector. So any point on this perpendicular bisector is equidistant from the endpoints. So if I actually measured any point here with my ruler, if I actually measured here, oops, if I actually measured this line here from the very top point, it's about 3.5 inches from that very top point to B. If I do the same thing from A, if I measure from point A to the very top of the arc, it's about 3.5 inches. So it should be exactly equidistant if you do it perfectly. So our next step is to write the converse of the perpendicular bisector, because in this case the converse is also true. So the perpendicular bisector says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. The conjecture, or the converse, remember, switches the if and the then part. So if I switch around the if and the then part, I get if a point is equidistant from the endpoints, then it is on the perpendicular bisector of the segment. So let's think about that for a second. It says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of a segment. So if you look at your diagram that you drew, that's saying that any point that's equidistant from A and B would be on the perpendicular bisector. So if we extended that out, that would be true. Any point here is going to be the same distance away from A and B. All right, now you have two more vocab terms on this slide, and that is the median and the midsegment. And they look kind of similar because they both talk about middle, but the median is a segment that connects the vertex of a triangle to the midpoint of its opposite side. So with the median, you always come from the vertex and go to the midpoint. So come from the vertex and go to the midpoint. That's the segment. That segment that's formed between those 2 points is the median. But with the midsegment is a little bit different because it doesn't connect a vertex to anything, it connects to midpoints. So the segment that connects the midpoints of 2 sides of a triangle is the midsegment. So with the midsegment, we come from here, this midpoint, to this midpoint. And then we could also go to this midpoint. This would be another midsegment. And this would be our third midsegment. With the median, if this is the midpoint, here's another median. And if this is the midpoint of this third segment, here is the other median. Right, so please jot down any notes you have from this lesson. Make sure you try the homework problems and refer back to previous slides on this presentation to help you out with the construction part. And if you have any questions, please bring them to class and we can go over them. Thanks.